with our exponential and linear functions, we have something called arithmetic and geometric sequences. By the end of this lesson, you should be able to think reasonably to discover and continue a number pattern. You should be able to form arithmetic and geometric sequences, and then use their formulas to continue a pattern. So a sequence is just a number pattern, and it could be absolutely anything, like 1, 2, 3, 4 is a number pattern. An arithmetic sequence is one formed by adding a number to the previous term. Now this number that you add could be positive or negative, so it could be getting bigger or it could be getting smaller, like 1, 3, 5, 7. The common difference is the fixed number being added every single time. So in this example, our common difference was a positive 2. I added that every single time to get the next one. I want you guys to come up with a new arithmetic sequence and tell me what the common difference is. And now a geometric sequence is one formed by multiplying a fixed number to each previous term. So if we start with 2 and then we do 4 and then 8 and then 16, we can keep on going. But what I'm doing every time is I'm multiplying by 2. And that 2 this time is called a common ratio. So come up with one of your own. The biggest difference here that you need to remember is common difference is a number being added or subtracted. Common ratio is a number being multiplied. So let's find the common difference of each sequence. What we're asking ourselves is, what do I have to do to each number to get the next one? So to go from 11 to 23, I got to add 12. And then double check that that works. If you do 23 plus 12, you definitely get 35. So the common difference is 12. Now the next one, you can see that these numbers go down, so our common difference is going to be something negative. So to go from 8 to 3, I got to subtract 5. From 3 to negative 2, I do the same thing. Then negative 2 to negative 7, do the same thing. So again, our common difference is negative 5. So this is a rule that allows us to figure out any number in the sequence without having to continue the pattern over and over again. And this is linear. We are adding or subtracting something over and over and over again. So this common difference right here tells us how to get to the next number. So now this is kind of confusing, but let's say we took a sequence like the 1, 3, 5, 7, 9, on and on and on. In order to figure out the next number in this pattern, you need to know the first term, so in this case that would be my A, and then the term number. So let's say we wanted to figure out the next term. We know what it is, but it would be our 1, 2, 3, 4, 5, 6th term. So we do plus 6 minus 1 times our common difference, and here we add 2 over and over and over again. So this ends up being 1 plus 5 times 2, or 11, which is what we knew that it was. So the thing you got to watch out for in this formula, and the reason why it's written this way, is you take into account the first term. And then this part right here, because we already used up the first term, we have to say this is the second term, this is the third term, this is the fourth term. But we multiply it by the common difference. So if we do n minus 1, 2 minus 1 gives us 1. So we multiplied it, or added the common difference, only once. Here we added the common difference twice. That's why we got to subtract 1. Here we added it 3 times. So we got to add, or subtract 1. So you will use this formula to find things like this. Find the first, 6th, and 12th terms of each sequence. So if I want to find the first term, that's when it's 1. So I do negative 5 plus n minus 1, so 1 minus 1 times 3. This ends up just being negative 5, because you get 0 times 3 here, which goes away. So my first term is negative 5. You could have seen that from just the equation also. 6th term, without having to write all the ones in between, all I got to do is plug this in. 6 minus 1 times 3. So you get negative 5 plus 5 times 3, or 10. So remember, this means that you added 5, or that you added 3, sorry, 5 times. That's your common difference here. I want you guys to find all of them for that one. So geometric sequences are pretty much the same, except they have a common ratio. And remember, that means multiplication. So ask yourself, what do you have to multiply by 750 to get 150? 150 to get 30, 30 to get 6. Now hopefully you notice numbers get smaller. So that means we're going to multiply it by a number less than 1. Now this is an easy one. I can do this in my head. It's 5. So then double check. 150 divided by 5 does give you 30. So that means I need to multiply it by 1/5 every single time. I start with something and I have 1/5 of it left over. So my common ratio is 1/5. Then this one, it grows, but it grows in negative land. So if I start with -3, to get to -6, all I gotta do is multiply by 2. And then -6 to -12, multiply by 2, same thing with this. So my common ratio is just 2. So here's the geometric sequence equation, and this one is exponential. We are multiplying by something every single time. So it looks almost the same. You still have your first term here, just like we did in the other one. This time our common ratio is our base in the exponent, and then that n-1 thing is our exponent. So find the first 6th and 12th terms of each sequence, just like we did before. If we want to find the first one, remember we could look at the equation, but also if we plug it in here, we have 4 times 3 to the 0 power. If you plug that in your calculator, it just gives you 4. Now the 6th one, we can plug this in. You get 4 times 3 to the 5th power. And if you do that in your calculator, 3 to the 5th power gives you 243. And if you multiply that by 4, you end up with 972. So obviously these ones get bigger quicker because they are those geometric, which means exponential curves. I want you guys to do that one on your own. So the other type of questions you'll get is just like the ones that we did in class, where I asked you, is this linear or exponential? Except this time I'm asking you, is it arithmetic or geometric? So you have to ask yourself, how do you go from one number to the next? I always check addition first, because it's a little easier. If I add 2, I can add 2, and I can add 2. So because I added the same thing, this is arithmetic. And if it asks you, my common difference is 2. Now the next one starts with the same number, the same 2 numbers. But if you notice from here to here, you're not adding 2 again, you're multiplying by 2. And since it works for all of them, that means that this is geometric. And my ratio would be 2. Everything's getting twice as big every single time. And then finally the last one, to go from 1 to 3, all I gotta do is add 2. 3 to 5, add 2. 5 to 7, add 2. So again, this one's arithmetic. And my common difference is 2 again. So even though I started with a different term, and it will never actually line up with that one, my common difference is still the same. So you should be able to do all of these things, answer those 2 questions, and then do this one. Determine whether each sequence is arithmetic or geometric. Make sure you write down any questions you have, and we can go over them in class. Have a good night.